In this section, we will review the properties of exponents, which will become really important in Chapter 1. First property, this is the product rule of exponents. If you multiply two exponents with the same base, we add the powers. So for example, if we multiply x to the fourth times x to the fifth, we are multiplying two exponents with the same base, so we add the exponents and we keep the base. Okay, so let's keep the base and add the exponents, which gives us x to the ninth power. Okay, so once again, if you multiply the same base, add the exponents but keep the base. Second rule is called the power rule of exponents. If you have a power to another power, you multiply the two powers together. So if you have a to the m raised to the nth power, so notice we have a power raised to another power, then the two powers get multiplied. For example, if we have x to the fourth raised to the fifth power, because we have a power to a power, we multiply 4 times 5, and we get x to the 20th. So note the difference between these two these two rules. In the first rule, the product rule, we have a product, which means multiplication of two different bases. Here, in the power rule, we have one base but two different powers. Okay, here's some examples. Let's simplify 6x cubed times 2x to the fourth. So the way I usually do this is I put similar terms in one parenthesis. So we'll have a 6 and a 2. So I'm going to put 6 times 2 in one parenthesis and the x cubed times x to the fourth in the second parenthesis. 6 times 2 is 12. When you have x cubed times x to the fourth, if you multiply the same base, we add the powers and keep the base. So this gives us 12x to the seventh power. Example 2. Let's simplify negative 4x to the fifth parentheses to the fourth power times 2x squared. With these problems, the best way to do this is to go step by step, not doing anything in your head, but showing all your work and doing everything step by step. So when you have an expression raised to the fourth power, each individual part of that expression, so negative 4 gets raised to the fourth. Then we have x to the fifth that gets raised to the fourth, and we still have a 2x squared on the outside. Okay, so when you have a parentheses raised to a power, take each individual part of the parentheses and raise each of those parts to the fourth power. So negative 4 to the fourth power is negative 4 times negative 4 times negative 4 times negative 4, which is positive 256. This is the power rule because you have a power to a power. That's x to the 20th. And we multiply this by 2x to the second power. Okay, now by the product rule of exponents, if you multiply the same base, we have to add the powers. But before that, let's separate this into 256 times 2 times x to the 20th times x to the second power. So if you multiply 256 times 2, then this will give us 512. If you multiply the same base, we keep the base, add the powers. This gives us 512 x to the 22nd power. Let's try one more. We have 3x squared times parentheses 5x cubed to the second power. So the 3x squared stays the way it is. Because we have a whole expression raised to the second power, we have 5 squared times x cubed squared. Okay, individually, we raise the 5 and the x cubed to the second power. Okay, so once again, the 3x squared stays the way it is. 5 squared is 25. X cubed to the fourth power is x to the sixth. So in one parentheses, we put 3 times 7, 5. In the other parentheses, we put x squared times x to the sixth. So 3 times 75, this should be 3 times 25. I'm sorry. 3 times 25 is 75. X squared times x to the sixth, you multiply the same base, so we keep the base, add the powers. This gives us 75 x to the eighth power. Next, we got the quotient rule of exponents. If you divide the same base, we subtract the powers. And it's always the power of the numerator minus the power of the denominator. Doesn't matter which one's bigger, which one's smaller, always go numerator minus denominator for the powers. So, for example, if I want to simplify x cubed divided by x to the third, because I'm dividing the same base, I keep the base and I subtract the powers, which gives me x to the fourth. Okay, it's always the power of the numerator minus power of the denominator. Anything to the zero power is defined as 1. So this to the zero power is 1. It doesn't matter what it is. Anything to the zero power gives you a 1. I quickly want to talk about why that is. Let's think about how we get a zero exponent. Let's say we have x to the fifth divided by x to the fourth. This will give us x to the 5 minus 4, which is x to the first. For us to have a zero exponent, we would need to have x to the fifth divided by x to the fifth, because this will give us 5 minus 5, which is x to the 0. But the reason we got the zero exponent is because we have x to the fifth, x to the fifth. We got the same exponent on the numerator, same exponent on the denominator. So essentially, we're dividing the same thing by itself, which equals to 1. Therefore, anything to the zero power equals to 1. Negative exponents. Once again, these are going to be really important in chapter 1 and onwards. If n is a positive integer, and if a is a non-zero real number, so if a is not equal to 0, then a to the negative n is 1 over a to the n. In other words, in order to make any exponent that's negative into a positive exponent, we move it to the denominator. And if the exponent is on the denominator, we move it to the numerator to make it positive. Okay, for example, 3 to the negative fourth will be 1 over 3 to the fourth. We want to make this a positive exponent. How do we do that? We move it to the denominator. 3 to the fourth is 3 times 3 times 3 times 3. So our answer here is 1 over 81. The next one, I have 1 over 5x to the negative third. Now we got to be very careful. This negative exponent, it only belongs to the x, not to the 5. So because the 5 has a positive exponent, it's going to stay exactly where it's at. We only move terms with negative exponents. So this x to the negative third moves to the numerator using this property. If you have a negative exponent to make it positive, you move it to the other side. So the x to the negative third moves to the numerator and then it becomes positive. So our answer is going to be x to the third all over 5. Keep messing up that 3, sorry. Lastly, we have 7 to the third divided by 7 to the sixth. Now by the quotient rule, which we went over in the previous slide, if we divide the same base, we subtract the powers, it's always a numerator minus denominator. So in this case, we are dividing the same base, so it's always a power of the numerator minus power of the denominator. So 3 minus 6, this will give you 7 to the negative third power. But our final answer can only contain positive integers or positive exponents. So we are going to rewrite this as 1 over 7 to the third. Once again, because our final answer can only contain positive exponents. 7 times 7 times 7 is 343. So our answer here is going to be 1 over 343. Okay, next we talk about rational exponents. The word rational refers to a fraction. So rational exponents are exponents that are fractions. If you have a to the m over n power, here's the rule. The denominator always becomes a root, and the numerator always becomes the power or the exponent. Okay, so for example, if I have the fifth root of x cubed, and I want to write this using a rational exponent, which means our exponent has to be a fraction, then we got the base 3. The root becomes the denominator of the fraction, and the power becomes the numerator. So that's going to be x to the 3/5. Next, write x to the 2 over 7 using radical form. So this form is called radical form. This is called exponential form. So we have, I'll rewrite this. We have x to the 2 over 7. Our denominator is 7, which means we have the 7th root of x. And our numerator is 2, so that's all going to be to the second power. Here's an example. We have 5 to the 4 over 9 times 5 to the 5 over 6. First of all, The product rule tells us that if we multiply the same base, we need to add the powers. So because we're multiplying the same base, we keep the base and we add the powers. So it's 4 over 9 plus 5 over 6. Once again, keep the base, only add the powers. When we add fractions, we need a common denominator. So between 9 and 6, our common denominator is going to be 18. Okay, so 9 times 2 is 18, and 4 times 2 is 8. 6 times 3 is 18, and 5 times 3 is 15. So we get 5 to the 8 over 18 plus 15 over 18. Now that we have a common denominator, we can add the numerators. 8 plus 15 is 23, divided by 18. And then notice it says write the final answer in radical form. So we have the 18th root of 5. Why? Because the denominator always gives you the root, and the numerator always gives you the exponent. So that's going to be the 18th root of 5 raised to the 23rd power.